Good morning dear students, welcome back. I am your physics professor Dr. Nagaraj. So I am explaining selected questions on modern physics and quantum mechanics. This is my third video on this particular module and this is for applied physics for triple E stream, electrical, electronics and allied branches. You just go through my previous videos. There I have explained something about matter waves, de Broglie concept of matter wave, derivation of the lambda expression, that is h by mv, uncertainty principle, group velocity, phase velocity and non-existence of electron inside the nucleus. And also we have set up the Schrodinger wave equation, that is one of the fundamental equation for quantum mechanics. Now we will see the applications of Schrodinger wave equation. Here comes the question. This is one of the important question not only for the internal test, even for the main exam also. The question is, starting from Schrodinger time independent wave equation, derive the expression for energy, eigenvalue and eigenfunction for an electron. Not necessarily electron, it can be any particle present in one dimensional potential well of infinite height or infinite depth. See, this is one of the fundamental application, basic application whenever we teach quantum mechanics and Schrodinger wave equation. Potential well, it is something like our normal well only. So whatever the well you see in your village or in your farm or in your field, ಜಮೀನಲ್ಲಿ ಹಳ್ಳಿಗಳಲ್ಲಿ ಬಾವಿ ಅಂತ ಕರಿತೀವಲ್ಲ, that same well, that is gravitational potential well. Here we have potential well, gravitational energy, electrostatic potential energy, like that. So whenever a particle is inside the well, it has to possess mgh of energy to come out of the well. You just imagine a person who is in the well. ಈಗ ಬಾವಿ ಒಳಗಡೆ ಯಾರೋ ಬಿದ್ದುಬಿಟ್ಟಿದ್ದಾನೆ. He has to come out of the well. What to do? He has to possess that m is his mass, g is the acceleration due to gravity, h is the depth of the well. Either he only can have that energy. Normally he don't have that much of energy. Assume that he don't have energy. Then you have to give energy from outside and lift him up. As long as he is in the well, we treat his energy as zero. And if the height of the well is infinite, then we call that well as infinitely deep. The depth is infinite, but width of the well is finite. So this is the background of the potential well. Now I have this potential well. Look at this well. This is the potential well, and these lines represent that the depth is infinite, and here is the particle. This particle is unable to come out of the well because it is not having sufficient energy. If at all particle want to come out of the energy, it must possess infinite potential energy. But I said inside the well, its potential energy is zero. Only potential energy is zero, not kinetic energy. That means particle can move to and fro. So it goes like this, comes like this, goes like this and comes like this. So it keeps on moving to and fro. If the motion is restricted to only x axis, we call it as one dimensional. If the motion is in the space, then it is called three dimensional. And for the sake of simplification, I take only one dimensional potential well. And now I impose some boundary conditions. Dear students, this well is having a width of a. So this is the starting point of the well. So this corresponds to x is equal to 0. This corresponds to x is equal to a. So this is outside the well and this is also outside the well. Well, now the boundary conditions. Probability of finding the particle, that is wave function, and potential energy V, wave function is 0, potential energy is infinity outside the well. Of course, this is one of the possible boundary condition, but because outside the well particle is not present, therefore psi equal to 0. And just now I said, in order to come out of the well, particle has to possess infinite energy, therefore V is equal to infinity. This is one boundary condition. Another boundary condition, inside the well particle is very much present, therefore psi not equal to 0. Psi is not equal to 0 and V equal to 0. I said inside the well potential energy 0 but not kinetic energy, that is inside the well. How do you define inside the well? Very simple, 0 to a, that is x is between 0 and a. So this is x equal to 0 and this is x equal to a. Anywhere from here to here is 0 less than x less than a. That is second condition. Number 3, psi equal to 0 for x not only less than 0 means here outside, not only greater than a, that means here, even at x is equal to 0 also, at x is equal to a also. That means right on this wall, probability of finding the particle is 0, because we make one assumption. What is that assumption? See, all these things you have to write in wordings, and of course the notes I have given in the description box. You can use that link and download the notes. What assumption I have made? When particle goes and hits the wall, I treat the collision as elastic. Wall is hard, ball is rigid. When it hits the wall, immediately it rebounds back. Suppose if the wall is not hard, let us say it is made up of mud, then when ball goes there and hits, it gets stuck into the wall. That is not possible here, because I assume that wall is hard, ball is hard, collision is elastic. So each time when the particle hits the wall, either this wall that is at x equal to 0 or this wall that is x is equal to a, collision is perfectly elastic. Therefore here also you cannot locate the particle, here also you cannot locate the particle. So x equal to 0, probability 0, x equal to a, probability 0. So with this much of boundary conditions, now let us start with the derivation. This is slightly lengthy derivation. Now I will take up step by step. Okay, first case 1. Okay, so when I write case 1, case 1 is outside. There are two cases. First case, outside the well, that is when x is greater than a, definitely v equals infinity. Now consider, see, whenever you write a condition, you have to consider the Schrodinger wave equation, that is d square psi by dx square plus 8 pi square m by h square into e minus v into psi equal to 0. This is our Schrodinger wave equation. Now I substitute for v, put v equals infinity. Therefore d square psi by dx square plus 8 pi square m divided by h square e minus infinity into psi equal to 0. Okay, now think of the possible solution. For what value of psi? See, what do you mean by solution? When you substitute some value for psi, LHS must be equal to RHS. Okay, suppose if I substitute 0 for psi, then definitely LHS is 0, RHS is 0. Therefore I can say psi equal to 0, let psi equal to 0, then 0 is equal to 0. Therefore psi equal to 0 is a solution, Now the question, is it an eigen solution or not? Means, is it an acceptable solution or not? Yes, it is an acceptable solution. How do you say it is acceptable solution? See, if psi equal to 0, what we can say? Outside the well, particle cannot be seen. Psi equal to 0 means probability of finding the particle outside the well is 0. This is the meaning of psi is equal to 0. So this is one of the acceptable solution. Okay. Now let us go to, let us go to second case. Now the case number 2. So this is very lengthy derivation. Please practice this once or twice. Case 2 I will write here. Case 2. This time I take outside the well. Not outside the well. It is inside the well. So inside the well, what is the probability? Inside the well, that is 0 less than x less than a, definitely v equal to 0. That is our one of the boundary condition. This is the boundary condition. Okay, therefore Schrodinger wave equation, d square psi by dx square plus 8 pi square m divided by h square into e minus v. In the place of v I write 0 into psi equal to 0. So this becomes d square psi by dx square plus 8 pi square m e divided by h square psi equal to 0. I call it as equation 1. Now for equation 1 also psi equal to 0 is a solution, because if you substitute 0 here and substitute 0 here, definitely if you nodi, for example, if you put 0 here, the first term becomes 0. If you put 0 here, second term also becomes 0. So that LHS is equal to RHS. But can we accept it? No sir, we cannot. Why? Because look at the second boundary condition. 0 less than x less than a, psi is not equal to 0. That means there is particle inside the well. Therefore, this time psi equal to 0 is not a solution. We will try to find the solution. So it goes like this. Put 8 pi square me divided by h square is equal to some k square. Call this as equation 2. Okay. Therefore, equation 1 becomes d square psi by dx square plus k square psi equal to 0. This is my equation number 3. Now, equation 3 is a second order differential equation. For this, we have to find the solution. Dear students, I directly write the solution without deriving it. Actually, there is a procedure to find the solution, but here it is not necessary. Straight away you can write. The solution for this equation is psi is equal to some constant c into kx plus some constant d into sin kx. I call this as equation number 4. Here c and d are constants. We have to find the values of c and d. Definitely c and d are constant. They may be, one of them may be 0, may not be 0, but definitely both of them cannot be 0. Eradu 0 irak sadhya illa. By chance, if both of them become 0, what actually it means, you know, if c is 0, d is 0, then psi is equal to 0 plus 0 tara agobidutte. That means once again we end up with psi equal to 0. That is not an acceptable solution. What I mean to say, either c may be 0 or d may be 0, may not be also, but definitely c and d both are not equal to 0. Okay, now let us find the values of c and d. I go ahead. Okay, first step, to find c. What I will do, I will apply boundary condition. Let x equal to 0 and psi equal to 0. I told you, no, right at this wall there is a 0 probability. Right here there is 0 probability. This is x equal to 0 wall. This is x is equal to a wall. Now let me apply the boundary condition to equation number 4 in equation 4. Therefore, nodi 4 equation illide 0 is equal to c cos 0 because I have taken x as 0 plus d sin 0, k into 0 is 0. That is 0 is equal to c cos 0 is 1 plus d into sin 0 totally 0 implies c is equal to 0. Dear students, follow carefully. I have got the value of c, which is nothing but now 0. So clearly tells you that d is not 0. Agle helde alva, either c is 0 or d is 0. If c is 0, d cannot be 0. Okay, we will see what is the value of d. So next step, second step, again that is to find d. Nodana d barutta ilva check madana. Let us find the value of d. Again put athwa let, this time I take x is equal to a and psi equal to 0 once again in equation number 4. I told you, no, this wall corresponds to x is equal to 0, this wall corresponds to x is equal to a. Okay, now equation 4 becomes 0 is equal to c cos ka plus d sin ka. Okay, 0 is equal to, anyway c is 0, therefore this whole term becomes 0 plus d sin ka. That implies d sin ka must be 0. Okay, well, let me go to the next page. Well, we have got this result d, right, d sin ka equal to 0, therefore sin ka equal to 0, because we know D cannot be 0. D 0 ಆಗಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ ಅಂತ ಗೊತ್ತಾಗ್ಬಿಟ್ಟಿದೆ ನಮಗೆ. Therefore KA must be sine inverse of 0. And you know sine inverse of 0 is nothing but 1 pi, 2 pi, 3 pi, 4 pi, etc. including 0. Therefore in general I write KA is equal to n pi. ಇದನ್ನು PUC ನಲ್ಲಿ ಹೇಳಿರ್ತಾರೆ. Therefore K is equal to n pi divided by A. I call this as equation number 5. Are you following? I hope you are following. See, in the previous slide I have this equation, that is equation for K. Look at this equation, that is equation number 2. This is equation number 2. Now I am going to substitute for K in the next slide. So coming to equation number 5, substitute, you can write substitute, please write all these details. Substitute equation 5 in equation 2, we get, yes, what we get? 8 pi square me divided by h square is equal to k square, that is n pi by a whole square. K square ittu, in the place of k I am writing n pi by a. Well, simplify, pi square cancel, so I have 8 me by h square is equal to n square by a square. I want e alone, that is n square h square by 8 ma square. So it is where n is 1, 2, 3, etc. Since it is depending on n, I write this as En. So this is the equation for energy eigenvalue. So one part complete ಆಯಿತು. So I have derived the expression for energy eigenvalue. The En is equal to n square h square by 8 ma square. If you take n is equal to 1, then this E becomes h square by 8 ma square. This is the lowest energy that particle can possess, and this is called 0 point energy or ground state energy. Both are same, ground state energy. Because it is 0 point energy, I write this as E0, not E1. If you write it as E1, it becomes first excited state. That means second level. See, we know energy levels are discrete. Ground state, this is E0. Next state is E1. Next state is E2. But when it comes to n, this is n equal to 1, n is equal to 2, n is equal to 3, and so on. So this is the expression for energy eigenvalue. But still we don't have any clue about D value, therefore wave function still not yet solved. Well, let me continue further. So wave function, back to this previous slide. See, in the equation solution for the equation, see, this is equation number 4. I know C value, I know K value, but I don't know D value, so I will write it now. So go to the next question, next step. I write the equation 4 like this. So equation 4 I rewrite here. Therefore equation 4 becomes, what is equation 4? Psi is equal to C cos kx plus D sin kx anta ideyalva. Now substitute for C, that is 0, plus D I don't know, into sin of k I know, n pi by a into x. Therefore psi is equal to d sin n pi by a into x. This is my equation number 6. So this is the equation for wave function, but still I don't know the value of D, so I will try to evaluate D now. Okay, so the next step, to find D value, to find D, this is also called as a normalization. Okay, well, already in the previous video I explained what is normalization. See, this is very lengthy question, that's why I said this is very important also. Okay, not only from the point of examination, even from the point of application of Schrodinger equation, this is quite important. Okay, now coming to application, to find the value of the normalization. Well, in my potential, well, I have x is equal to 0 to x is equal to a. So from here to here I have to find the probability. So integral of modulus of psi square dx equal to 1 from 0 to a, from 0 to a. Well, substitute for psi square. So integral of psi, that is d square sine square n pi x divided by a into dx is equal to 1 between the limit 0 to a. Okay, so d square you can take common factor, integral of sine square n pi x by a into dx is equal to 1 between the limit 0 to 1. Okay, now take this trigonometric identity, that is sine square theta is equal to 1 minus cos 2 theta divided by 2. This is one of the known equation. On that basis I write d square integral of 1 minus cos 2 theta. In the place of theta I have n pi by a x. Okay, into dx. This whole thing divided by 2, that divided by 2 I write outside between the limit 0 to a. I hope you are following. Okay, let us proceed further. This becomes d square by 2 integral of 1 into dx minus d square by 2 integral of cos 2 theta, that is 2n pi x by a into dx, that is equal to 1. In both the cases limits are 0 to a, 0 to a. Okay, well, this becomes d square by 2 integral of dx is x between the limit 0 to a minus d square by 2 integration of cos is sine 2n pi by a x. Limits between the limit 0 to a is equal to 1. Now dear students, please apply the limits. It becomes d square by 2 into a minus 0. Of course, divided by 2n pi by a. This is the integration of cos 2 theta minus d square by 2 into a divided by 2n pi. This whatever is there in the denominator goes to numerator into sine of 2n pi by a x between the limit 0 to a is equal to 1. Okay, this is d square a divided by 2. Okay, minus d square a divided by 4n pi into, see, please try to solve this on your own. When you apply upper limit a in the place of x, the first term becomes sine 2n pi. Okay, minus when you apply the lower limit it becomes sine 0. So is equal to 1. That is d square a divided by 2 minus, look at this, sine 2 pi is 0, sine 0 is 0. So whole second term becomes 0. Please try to convince yourself. The whole second term becomes 0. So that d square a by 2 equal to 1 implies d square is equal to 2 divided by a. So that d is equal to root of 2 divided by a. So like this we have to find the d value. So d value is evaluated. Now let us go to next point. Equation number 6. In equation number 6 I have d value. Here I calculated the d value. It is d is equal to root of 2 by a. So I combine and okay, if you want you can call this as equation 7. Substitute equation 7 in 6. We get psi. I write in the bottom because there is no enough space. So psi is equal to root of 2 by a sine of n pi by a into x. So this is the expression for eigenfunction. And since we have n here, I write psi n. So the lengthy, this is very lengthy derivation, but it is quite important derivation also. So all these steps are available in my notes. Please go through it. Well, I stop this video here. I have one more question to discuss that I will take in my next video, and immediately I will come back to you with videos on lasers and optical fibers. Okay, please stay with me. Thank you very much.